For your entire life, you've been told the universe is big, unimaginably big. But what if everything we thought we knew about its size was wrong? Not just a little off, fundamentally, laughably wrong. Because that's exactly what the James Webb Space Telescope just showed us. And honestly, the numbers are so insane that even the scientists who found them had to double-check their own work. What Webb discovered doesn't just change how big we think the universe is. It changes what the universe even is. And by the end of this video, the way you see your place in existence will never be the same again. Stay with me, this one's going to blow your mind. Let's rewind for a second. Before James Webb, we had Hubble, and Hubble was incredible. Back in the mid-1990s, astronomers pointed Hubble at what looked like a completely empty patch of sky. Just pure darkness, nothing there. They kept the shutter open for 10 straight days, and what came back shook the entire field of astronomy. That tiny patch of sky, no bigger than a grain of sand held at arm's length, was packed with over 3,000 galaxies. Not stars, galaxies, each one containing hundreds of billions of stars. Each one potentially harboring worlds we can't even imagine. From those deep field images, scientists did the math. They took that small patch, extrapolated it across the entire sky, and landed on a number, roughly 200 billion galaxies in the observable universe. 200 billion. That was the number that stuck. That was the figure in every textbook, every documentary, every classroom for years. And people thought, okay, that's the answer. The universe has 200 billion galaxies. Case closed. Except it wasn't closed, not even remotely. In 2016, a team led by Christopher Consolis at the University of Nottingham took those same Hubble images and ran a much deeper analysis. They converted the images into 3D models, ran new mathematical simulations, and realized something staggering. The galaxies Hubble could see were just the tip of the iceberg. Over 90% of the galaxies out there were too faint, too far, and too small for Hubble to detect. Their revised estimate? Not 200 billion, 2 trillion galaxies. Let that hit you. 10 times more galaxies than we thought. And even that number, as we're about to see, might still be too low. Then came the James Webb Space Telescope. Launched on Christmas Day, 2021, Webb was built for exactly this kind of work. Its gold-plated mirror stretches 6.5 meters across, giving it over 6 times the light-collecting area of Hubble. While Hubble saw mostly invisible and ultraviolet light, Webb sees in infrared. And that changes everything. Here's why infrared matters so much. The universe is expanding, and as it expands, light from distant galaxies gets stretched out. It shifts from visible wavelengths into infrared wavelengths. Hubble literally could not see the most distant objects in the universe because their light had been stretched beyond what Hubble's instruments could detect. Webb doesn't have that problem. It was designed to catch exactly that kind of ancient, red-shifted light. And when astronomers pointed Webb at what looked like empty sky, the results were staggering. Where Hubble saw a few thousand galaxies in a deep field, Webb saw over 25,000, in an area no bigger than a grain of sand at arm's length. And these weren't just faint smudges. Some of them were fully formed spiral galaxies, complete with complex structures, existing at a time when they simply should not have existed yet. The Cosmos Webb Survey, the largest observing program Webb undertook in its first year, surveyed a patch of sky roughly the width of 3 full moons, side by side. It's the widest observation area Webb has ever covered. And the team behind it processed over 10,000 individual images, carefully correcting for artifacts and distortions that had never been encountered before. The result? A panoramic map of the early universe, so detailed that astronomers are still sifting through it. And what they're finding keeps challenging what we thought we knew. But the real bombshell came when Webb broke its own record. Again. In January 2026, NASA announced that Webb had confirmed the most distant galaxy ever detected. It's called mome Z14, and its light has been traveling toward us for approximately 13.5 billion years. That means we're seeing this galaxy as it existed just 280 million years after the Big Bang. Think about that for a moment. The universe is roughly 13.8 billion years old. Mome Z14, existed when the cosmos was barely 2% of its current age. It's like looking at a photograph of a human being taken just a few days after conception. And here's the thing that has scientists scratching their heads. Mome, Z14 is way too bright, way too compact, and way too chemically complex for something that young. It contains elevated levels of nitrogen, which suggests that massive stars had already formed, lived their lives, and exploded before this galaxy's light even started its journey to us. Rohan Naidu from MIT, who led the research team, put it bluntly. He said, "They're able to see farther than humans ever have before, and it looks nothing like what they predicted," both challenging and exciting at the same time. And mome, Z14 isn't an anomaly. It's one of a growing collection of surprisingly bright, surprisingly mature galaxies in the early universe. Webb is finding 100 times more of these early galaxies than theoretical models predicted before launch. Jacob Shen, a postdoctoral researcher at MIT, described it as a growing gap between theory and observation when it comes to the early universe. Theories said these galaxies shouldn't be there. Webb says they are. And that gap between what we expected and what actually exists keeps getting wider. So what does this mean for the actual size of the universe? Let's talk numbers, and brace yourself, because these numbers are going to feel almost meaningless. That's actually the point. The observable universe, the part we can theoretically detect, is about 93 billion light-years in diameter, not 13.8 billion, even though the universe is 13.8 billion years old. The difference comes from the fact that space itself has been expanding the entire time. Objects that emitted light 13.8 billion years ago are now 46 billion light-years away in every direction. That's just the observable part. The observable universe likely contains somewhere between 200 billion and 2 trillion galaxies, with newer estimates pushing that number as high as 6 trillion, possibly even 20 trillion when you count all the tiny dwarf galaxies that are too faint to see. But here's where it gets truly wild. The observable universe is almost certainly a tiny fraction of the actual universe. Some researchers have estimated that the observable part represents maybe 3% of the total. Others have run statistical analyses suggesting the full universe is at least 250 times larger than what we can observe, stretching roughly 7 trillion light-years across. And if certain models of cosmic inflation are correct, meaning the universe expanded exponentially fast in its first fraction of a second, then the total universe could be more than 10 to the power of 100 times larger than the observable one. That's a 1 followed by 100 zeros. If the universe is infinite, then the number of galaxies is also infinite. Every single star you see in the night sky belongs to just one galaxy, the Milky Way, and the Milky Way is just one among what might be trillions upon trillions of galaxies. Every one of those galaxies contains billions of stars. Every one of those stars could host planets. And we're only now beginning to realize how much of this we've been missing. Webb's contribution to this understanding isn't just that it found more galaxies. It's that it showed us galaxies where they shouldn't have been, formed faster than they should have, and existing in numbers that break our models. The universe isn't just bigger than we imagined. It's bigger than we were capable of imagining. And then there's the expansion problem, because it's not just the size of the universe that Webb has forced us to rethink. It's the speed at which the universe is growing. And this is where things get genuinely strange. For decades, scientists have been trying to nail down a number called the Hubble constant. This number tells us how fast the universe is expanding. Measure it one way, using nearby stars and supernovae, and you get one number. Measure it another way, using leftover radiation from the Big Bang, called the cosmic microwave background, and you get a different number. These two numbers should match. They don't. This discrepancy is called the Hubble tension, and it's been haunting cosmology for years. Some scientists hoped that Webb would solve it, that better instruments would reveal some measurement error and make the problem disappear. Instead, Webb made it worse, or rather, Webb confirmed that the problem is real. Nobel laureate Adam Riess and his team used Webb's first 2 years of data to cross-check Hubble's measurements. They used the largest sample of Webb data collected so far, employing 3 different methods to measure distances. The result? Hubble's original measurements were accurate. The tension isn't a mistake. Ries himself said that with measurement errors ruled out, what remains is the real and exciting possibility that we have fundamentally misunderstood the universe. Meanwhile, Wendy Friedman at the University of Chicago ran her own independent analysis using Webb data and 3 completely different methods. Her team measured a Hubble constant of about 70 kilometers per second per megaparsec, which overlaps with the other major method, suggesting the tension might not be as severe as feared. But even she acknowledges that the debate is far from settled. So we're left with a universe that is expanding, and we can't agree on how fast. Some scientists are calling it a Hubble crisis, rather than just a tension. Because if our 2 best methods of measuring the universe give us different answers, then something fundamental about our model of the cosmos is wrong. And that's actually thrilling, because the last time physics had a crisis like this, it led to the discovery of dark energy. The time before that, it led to general relativity. Crises in physics don't just break things, they build entirely new frameworks for understanding reality. Webb is still in its early years. The telescope's 120-hour deep gaze at galaxy cluster Abell S1063, its longest observation of a single target, has already produced one of the deepest images of the cosmos ever captured. Gravitational lensing from that massive cluster is magnifying galaxies from the universe's distant past, revealing structures from the era astronomers call cosmic dawn. And there's more coming. NASA's Nancy Grace Roman Space Telescope, set to launch in the coming years, will combine high-resolution infrared imaging with an extremely wide field of view. Where Webb is like looking through a powerful magnifying glass, Roman will be like scanning with a wide-angle lens. Together, these instruments will take the handful of ancient galaxies Webb has found and expand that sample into the thousands. Every new data point pushes the boundary of what we know. Every record Webb breaks reveals another layer of a universe that keeps turning out to be more complex, more ancient, and more enormous than our best theories predicted. Here's what I keep coming back to. We live on a small, rocky planet orbiting an average star in one arm of an ordinary galaxy. And that galaxy is one among what might be 20 trillion others in just the part of the universe we can see. The full universe might be 250 times larger than that, or it might be infinite. The James Webb Space Telescope didn't just show us that the universe is bigger, it showed us that our imagination was too small. That every time we thought we had a handle on the scale of reality, we were barely scratching the surface. And the wildest part, we're just getting started. If this video made you see the cosmos differently, hit that subscribe button, because we're going to keep diving into the biggest mysteries the universe has to offer.